everyone. In this video, we are going to work with the multiple choice questions, especially on the counting and the relation counting. The first question we have in this case is, how many relations are there on a set with n elements? So relation on a set, suppose we have the set that is represented by A with n elements. Relation on a set A means it is a subset of A Cartesian product with itself. The total number of elements in a Cartesian product with itself is n into n. Now we need to count the subset. Maybe these elements are the part of set or may not. Means two possibilities. So total subsets are 2 raised to power n square, or we can say that total number of relation on the set is 2 raised to power n square. This is the one way to attempt this question. Suppose you forget this one. Another way is we can go with the help of matrices representation. So as per this, if we have the relation that is defined on a set with n elements, it means those n elements we will take as a row wise as well as column wise. So total elements in this matrix is what? N square. Now this element can be there or cannot be there. This element can be there, cannot be there. So these elements has two choices. So it means there are possibilities of getting 2 raised to power n square relations. So hence option A is correct. The next question is, how many reflexive relations are there on the set with n elements? So rather than counting the relations, now we need to count the reflexive relation. So with the help of matrices, we can evaluate this. Suppose we have the matrices. Now what is the order of this matrices? We have the n elements. So place that n elements row wise as well as column wise. So total elements. So total entries in the matrices is n square. Now reflexive means all the diagonal entries are 1, 1, 1, 1. Each diagonal entry has one choice. How many diagonal entries are there? That is the n. So it means 1 is get multiplied by 1 by n times, because n diagonal entries are there and each diagonal entry has one choice. Now what about the remaining elements? Remaining elements are n square minus n, because total entries are n square, diagonal entries are n, so off diagonal entries are n square minus n. Now the point is, maybe this entry is a part of a relation or may not, because for the reflexive we just putting a condition that diagonal entries are 1. Other can be there, cannot be there. It means n square minus n entries has two choices. So we can say that we will multiply 2 how many times? N square minus n. Make sure their sum is n square, because total entries is n square. So we can write this as 1 raised to power n into 2 raised to power n square minus n. And hence final answer is D. Another question we have, the number of relation from A to B with number of elements in a set A is 3 and number of elements in a set B is 3. Again answer this question with the help of matrices. So we have the relation that is defined from A to B. So we will collect all the elements of the set A in a row wise and elements of the B set in a column wise. How many entries are there in a A? That is 3. B, 3. So order of a matrix is 3 by 3. We need to count the relation. Maybe this entry is there, may not be. Even for this, maybe it is there or not. So each entry has two choices. So it's like 2 raised to power total number of entries, that is 9, and this is equal to 512, and hence option C is correct. Taking another example, let's suppose A has 3 elements A, B, C and B has 2 elements E and F. How many relations are there from A to B? So again we will get a matrix of order cardinality of the set A into cardinality of the set B. Total number of elements in A is 3, in B 2. So total entries, that is 6, because 3 as a first column and 3 as a second column. Total entries are 6. Now number of relations means this element can be the part of relation or a not. Again two choices, so 2 raised to power 6 is the answer in this case. Number of relation on a set A with these elements. So only one set is given to you. It means we need to take the relation from set A to A. So here we have the square matrices, 4 elements that is placed as a row wise and 4 elements as a column wise. Total entries, that is 16. So number of relation is 2 raised to power 16. Next question we have number of subsets of A cross A. This is basically asking the about number of relations on set A. So either write in this form or we can write number of subsets of A cross A. The meaning is same. We have already covered this one. Total number of entries is n square because n elements as the row wise and n elements as the column wise. So total entries are n square. Total subsets are 2 raised to power n square. It means none of the option is correct in this case. Use the n elements in a set. The number of symmetric relation is what? So it's very simple. We will take again a matrices form. Total entries are n, means number of entries in a rows is n, and as well as in column n entries are there. So total entries are n square. We will first divide into two parts, one as a diagonal entries, another as a off diagonal entries. So total entries are n square. How many diagonal entries are there in this case? Diagonal entries are n. Off diagonal, that is total entries minus diagonal. Now think, when the relation is symmetric, is there any restriction on the diagonal entries? Diagonal entries of the form ordered pair AA, and there is a no restriction on this one. Maybe it is a part of relation, may not. Means each diagonal entry has two choices. So for this one we have 2 raised to power n into of diagonal entries. Now think, if this entry is a part of relation, its reverse entry must be there. And if it is not there, then reverse should not be there. It means whenever we are working with this entry, that is above to the diagonal entry, we have already deal with corresponding lower diagonal entry. It means at a time we are working with both of the entries. If it is there, it should be there. If it is not there, it should not be there. Similarly, if we pick any entry from the upper diagonal area, if they are represented by 1, its corresponding lower diagonal entry will be 1. And if these entries are 0, then corresponding lower diagonal entry is 0. So it's like we are working with a pairwise. Here we have n square minus n entries in this area plus this area. As we are working with the pairwise, so we will just take the choices for the one case. Because if we are taking any entry from the upper diagonal entries, it means we have already covered the lower diagonal entries. So how many upper diagonal entries are there? Total off diagonal entries are n square minus n, and off diagonal entries are n square minus n by 2. Each of these entries has again two choices. So it means we have possible cases in this cases 2 raised to power n square minus n by 2. This is equal to 2 raised to power n plus n square minus n by 2. Simplify this, we have 2 raised to power 2n plus n square minus n by 2. That is equal to 2 raised to power n plus n square by 2. and hence option A is correct. Now what about the second case? Total number of symmetric relation on the set that contains the 7 distinct elements. Again we need to count the symmetric relation, but entries are 7. It means we need to put n is equal to 7 in this case. So substitute n is equal to 7, we have 2 raised to power 7 into 8 by 2. This is 4, that is equal to 2 raised to power 28. Hence option C is correct. Next question we have, let A is a set that contains these 4 elements. How many ordered pairs are in a relation such that we are taking ordered pair where A divides B? So how many elements are there? So first we need to identify whether 1 divides 1. Yes. Whether 1 divides 2? Yes. 1 divides 3? Yes. 1 divides 4? Yes. So means these are the part of the relation. Now think for the 2. 2 divides 1? No. 2 divides 2? Yes. 2 divides 3? No. 2 divides 4? Yes. For 3? 3 divides 1? No. 3 divides 2? No. 3 divides 3? Yes. And the last ordered pair we have 4 divides 4. So total ordered pair in this case we are getting as the 8. Next question we have, how many numbers must be selected from 1 to 6 to show that at least one pair of these numbers add up 7. Now from 1 to 6, what are the numbers when we take as a pair wise and its addition is 7? So if I take the pair 6 1, addition is 7, pair as a 5 2, addition is 7, pair as 3 4. Now we will choose the worst case. We will collect all those elements such that addition of two number is not 7. So we can collect the number as 6, 5, 4 in one set and 1, 2, 3 in one set. So in this case, none of the addition of two number is equal to the 7. But once we will add any number in the set, the summation of any two numbers will be 7. Let's suppose we are adding here as the one element. So sum of 6 and 1 is 7. Because the question is to be sure that at least one pair has addition 7. So कोई एक pair का addition 7 बनना चाहिए. So once we are adding the fourth number, we are getting a one pair whose sum is 7. Even in this case, if you take any number out of these one, suppose we are taking 5. So we are getting a one pair 2 and 5 whose sum is 7. It means minimum number selected to be 4. That is the answer. We have another question. Among 100 people, find the minimum number of people who were born in a same month. Now we have the 100 peoples. Total number of months is 12. Here we need to give the surety minimum number of people who were born in the same month. So what we can do here, we can apply the concept of generalized Pinson-Hole principle. 100 by 12 take its ceiling, that is 8 point something, that is equal to 9. It means at least 9 from 100 who were born on the same month. So answer in this case is D option.